Welcome to section 1.5. We're going to be talking today about data. And not just the quantitative and qualitative, but a few more aspects than that. We'll also be talking about collecting and recording data, or information, in other words, and how to organize it in charts, graphs, drawings, so that we can present it nicely. Let's start with quantitative versus qualitative, okay? We're going to talk first about the quantitative data. The two words are very similar, but quantitative comes from quantities, or numbers, values, things you can say how much, how many, how long. It's data that can be measured. We use numbers in quantitative data. We look at things like height, length, area, volume, weight, speed, time, temperature, humidity, sound levels, cost, number of members, ages, etc. to describe this kind of observation quantitatively. So let's look at an example. We're going to look at a coffee latte right here, and we're going to describe it quantitatively, okay? We're going to take down some quantitative data. We have 16 ounces of latte at 150 degrees serving temperature. The serving glass is 12 centimeters tall, and it costs $4.95. Those are all quantitative values. Now let's look at qualitative data. The word qualities or quality is associated with qualitative data. It deals with descriptions or data that can be observed but not measured. Okay, things that fall into this category would be colors, textures, smells, tastes, appearances. And let's do the same example with our latte here. Okay, we're going to describe it qualitatively. It has a robust smell, light brown appearance, strong taste, clear glass. Those are all examples of qualitative data. They're descriptions. So let's move to another category, now that we know the difference between qualitative and quantitative data. How do we organize our data? One thing I want you to really get used to is collecting and recording your data in very organized fashion, because it will help you immensely. Here is a chart that I took straight out of your lab, the Earthworm Behavior Lab. That chart is already provided, and you'll find that in our labs, a lot of the charts and tables are already given to you. So all you have to do is just fill them in, which is very convenient. But I'd also like you to learn how to create your own charts and tables. When you're doing an experiment, think, what data am I going to be recording, and what is the easiest way to set up a good chart or a good table in order to record this data? It will make your life easier when you're recording your data in the middle of your experiment, and also it will make it a lot easier to understand afterwards. So when we talk about organizing data, we also need to address the part after you're finished with your experiment where you report and present all of the data that you've collected. And you can do this in a variety of ways. You can make charts. Here's a flow chart that was created based on information from their experiment. It's a little flow diagram. Those can be very useful. They can be difficult to create and to come up with, but they're very useful when someone is looking at the data that you've made. Drawings are useful. If you are observing organisms, you can create drawings that can help someone understand your data. Graphs are incredibly useful, especially for the quantitative data that you collect. Here we have a pie chart. I'm sure you're familiar with those, where each slice is a percent of the whole, and those can be useful to help someone visualize your outcomes and your data that you've collected. Here is a line graph, and here is a bar graph. We're going to be mostly looking at those two. And we're starting with the line graph. It's possibly the most useful to us in science, and it helps us to understand our data. So a line graph is used when we are comparing two sets of related data. Here we'll have one set of data here and one set of data here. We have the x-axis and the y-axis. One useful outcome of a line graph is that we can predict data that's not directly measured. So let's say we plot these two pieces of data and we get a line. We can determine points on that line that haven't been directly measured. They're in between measurements or beyond the measurement. So they can be very useful for a number of reasons. Let's look at the steps that we need to take in order to create a line graph. First, we need to determine the variables. So I just set up a little example for us to help us be able to do this. Let's say we are to find out how long it takes to boil water, and we are to heat some measured amount of water over a Bunsen burner and record the temperature every minute. So I want you to pause this, think about what would the independent variable be here and what would the dependent variable be. All right, so hopefully you came up with the right answers. If not, that's okay. We're going to tell you what they are. The independent variable will go along the x-axis, and in this case, it's time, okay? And it's time in minutes. We always label our units on the axes. Here, the dependent variable is the temperature of the water in degrees Celsius. So those would be the variables, the two variables, and we put this one on the x-axis, this one on the y-axis. We want to, secondly, determine the scale of the axes. So for the scale across the bottom, we did this for 5 minutes. So we're going to space those 5-minute portions equidistant over the space that we have on our graph. You can do, when you're doing this on a graph that on graph paper that has lines this way, you're going to have little squares. You can take the total, say 100 degrees total on our data, and divide it by the number of squares you have, and that will also give you a way to spread those measurements equidistant over the space of your graph. You want to occupy the largest space that you possibly can. And once again, you want to for sure number and label with units each of the axes. So 3, we're going to plot our data now. So at 0, our water temperature is 49.5 degrees. So at time 0, we go up to 49.5 and put our little plot right there. And as we plot each of those pairs of data, we end up with our plots across our line graph. The fourth thing, before we do that, we want to draw a best fit line. And this is really easy because the line is so straight on this data that there isn't much concern over the best fit line. We just draw a straight line right here. I will show you in the next slide what to do when the data isn't quite that straight. But fourth, we want to do another key component of our graph, and that's title it. And here, this title actually would have probably been better suited to say temperature of heated water versus time, or something like that would have been a little bit more descriptive. But you definitely want to have a title so people know what it is that your graph is all about. If there is more than one set of data, you'll need to provide a key, and I'll show you that on the next slide. These examples of line graphs give you some idea of some different things that can go on. Right here, we have, actually, this graph is missing a title, so it's not a very good graph. We have our axes labeled and units of, provided. We do not have any measurements along here, so they're missing that, and they're also missing the title. But regardless of that, I wanted to show you an example of data that's been plotted. We would not do this little dot-to-dot method. That is not what we do. Instead, we do a best fit line that encompasses sort of the idea of the entire, all the plots, all the data. So that is a best fit line. That's an example of that. Here, they did actually do a little dot-to-dot. They didn't need to. They could have done a best fit line on some of these as well, or a best fit curve. Sometimes it's not a line, but it's more of a curve, and that's fine too. But the dot-to-dot method is not really very appropriate. Here, what I wanted to show you is that there were 5 comparisons. They did 5 different setups and compared them, and here is the key showing those different setups in a different color each. Here is an example of a plot that's a little bit interesting. There is a peak here, at which point there's a decrease. And unfortunately, they were really not able to put the lines on here because there's not enough data to know exactly where the peak is. It appears that it's there. However, it could be just to the right or just to the left of that plot. So a little bit more data is needed, and then they could do a best fit line of increasing and a best fit line of decreasing values. Here it would have been a nice curve if they would have done a straight curve, and they are missing a very important component, the title. So that's a bad graph too. Last kind of graph to look at is the bar graph. Bar graphs compare two sets of related data. However, if they're only comparing one variable, it's not called a bar graph technically, it's called a histogram. This is technically a histogram. There's only one variable being looked at, whereas this is a bar graph. It has the two sets of variables. So we construct a bar graph in a similar way as the line graph. We determine the variables. Oftentimes on the x-axis, we will use a qualitative we will use qualitative data across the x-axis, and the y-axis will contain the quantitative data. And it doesn't always have to be this way. However, if a bar graph is using quantitative data here and quantitative data here, oftentimes that would better be suited as a line graph. So that's just sort of a little rule of thumb you can use. You want to determine the scale of the y-axis, and you want to number it. Here they've numbered it. Label both axes with units. They could have said units here as percentages, would have been more descriptive, more complete. And then use the data that you have to create the bars on the graph. You want to title your graph and provide a key. They provided the key, especially because if it's a true bar graph, you're going to have more than one variable and you need the key there. So thanks for listening, and I hope this all makes sense to you. And if you want to do advanced proficiency kinds of things, use your imagination, be creative, and come up with some really great ideas for me. So thanks, and we'll see you in class.